Worksheet 2, number 9. Okay. Who asked? McKenna, did you ask for this one?
Oh, yeah.
So what did you think U should be?
2x minus.
Okay, I like that. So du is 2 dx. So, okay, I got to change an 8 to a 2. So this is where there's like the two options. I can multiply by a fourth on the inside and then a 4 on the outside. I could also just move the 8 out front and do a 2 and a 1/2. Either way, I end up with a 4 on the outside. Because I'm going to multiply by a fourth to get me to 2 dx. So there's du. 4 on the outside. Leaving my limits alone because I know those are x limits and I need to change them to u limits. And then I've got a cube root in the bottom. I don't like cube roots. I don't like things in the denominator. So I would like to write that as u to the negative 1/3. All right, negative in the bottom, 1/3 is the cube root. Okay. I need to change the limits. Unless you want to take the antiderivative, put the x stuff back in, and use the original limits. But I'm almost always going to change the limits. Again, for really the sole reason is I can write a test question to force you to change the limits, so you may as well get used to doing it. Okay, so top limit. If I plug in 7, 14 minus 6 is 8. So 8 is my top limit. My bottom limit. If I plug in 7/2, I get 7 minus 6 is 1. Okay. So now I've changed this entire problem. Everything was in x's. Now everything is in u's. The integrand is u. What I'm taking the antiderivative with respect to is u, and the limits are u. So I don't have to do anything with x's anymore in this problem. So increase the power by 1, I get to 2/3. Divide by 2/3, that's 3/2. Don't forget the 4 that's still out there. And we'll go from 1 to 8. So I'm going to leave the constant stuff out front. 12 over 2 is 6. And then 8 to the 2/3 minus 1 to the 2/3. And now that would be a safe stop. Obviously it's multiple choice, so I got to keep going. But this would be my first safe stop that I've hit. Let's see, 8 to the 2/3. That's the cube root of 8 is 2, and 2 squared is 4. And then 1 to anything is still 1. So 6 times 3 is 18. Is that what you got, McKenna?
Yeah.
Well done. A lot going on in that problem. I guess there's a lot going on in all those problems. One more, or are we good?
12.
Number 12. Oh yeah, 12 looks weird. The function f is continuous. And the integral from 0 to 8 of f of u du is 6. What is the value of 1 to 3? X times f of x squared minus 1 dx. Well, this whole unit, or this whole lesson is u substitution. So what do you think we should let u be? X squared minus 1, because then dx is 2x, and it starts to simplify, and it even starts to look a little bit like this one. So let's let u be x squared minus 1. Du then is 2x dx. So I need a 2 on that x, which means I need a 1/2 out front. So 1/2, antiderivative. I'm not writing the limits yet because those are x limits, and I'm going to need to switch them to u limits. The 2x dx, that's du. And then f of, replace the x squared minus 1 is u. Oh, now I'm getting close to the information they gave me. I hope these limits match up. If they don't, I don't know how I'm going to work the problem, but I bet it's rigged to work out. So if I plug in 3, 9 minus 1 is 8, so my top limit is 8. My lower limit, my lower x limit is 1, so I plug in 1. 1 squared minus 1 is 0. So my lower u limit is 0. And now that matches what they gave me. I was wondering what that was, but they now have told me that that is equal to 6. And so half of 6 is 3. So I bet that's an old AP test question. So that was a U substitution trick, and the main thing it was testing is that you took du and you fixed that dx, you put that 2 on the inside and 1/2 on the outside. Alright, anything else? We do actually have time for one more. The reason being is today's lesson is like a 2-day lesson, so we'll do the notes today and we'll just answer questions tomorrow. Because there's a assembly for 6th period for you guys. It doesn't affect us, but it does affect others, so we'll split that day up. Alright, all that to say, number 11. Well, same kind of thing here. I bet it's a U substitution. And then, what do we do from there? Function f is continuous. G is a function such that g prime equals f. Which of the following is equal to that in terms of g? So if I integrate f, I would get g. Yeah, the integral of f is going to be g. So that's why the integral of f gives me g. But I need to fix this 1/2 business. So, I don't know that I would remember to do this, except that I'm in the u substitution section, so I'm guessing du then is 1/2 dx. So I need a 1/2 on the dx, which means I need a 2 out front. And I'm in the process of switching over, so I don't want to write those limits down yet. 6 and 10 are x limits. I need u limits. So f of u du. I overkill with my coloring here. So the top limit in x's is 10. Half of that's 5. So the top limit in u land is 5. Bottom limit for x's is 6. Half of 6 is 3. So the bottom limit in u land is 3. Okay, so I got everything switched over from x stuff to u stuff. And if g prime is f, that would mean, like if I integrated both sides, that means that the antiderivative of f is g. And so that's why all my answers are g of something. So g of u from 3 to 5, but there's a 2 out front. So 2g of 5 minus g of 3, which would be answer choice C. So that one definitely tested that you changed the limits. That's where the 10 and 6 answer would come from. And it made sure you knew how to handle a du dx swap against the 1/2s on there. we're doing a bunch of different integrations over the next week and a half until we hit the test. But all of them involve U substitution. So today we're talking about natural logs, but it's still going to have U substitution. Monday it'll be e to the u, so U substitution. Inverse trig is a pain, but it'll still have U substitution. So we're going to start mixing it up, but you still have to remember this idea of let U, then fix the du, and then fix the limits. Yes, sir.